What? Where are you?
Recording in progress.
As people are trickling in, feel free to share where you're from. How's everyone doing today? Hello, Kevin, you're first. India, UK, hey, Canada.
Yeah, people from all over. Vietnam at times.
Awesome. Where else? For everyone else coming in right now, tell us where you're from. United States, that's too broad. Give us a state.
Somewhere north of Pluto.
Oh, it's coming in hot. Colombia. Very nice. Very nice. Anyone from Uruguay? Uruguay. I was there this year. That's why I'm wondering. Another Colombian. Buenos dias. Italy, lovely. Was there earlier this year. India. Oh, Montana. Nice.
Okay, yeah, it looks like we're evening out with participants. Should we jump in and get started?
It works for me.
Cool.
All right, folks. Welcome to Culling Techniques using Unity's CullingGroup API. This is sort of an extension of a webinar I did several months ago, in which we talked about all the various culling groups or culling techniques inside of Unity. This time we're going to do a deep dive into the CullingGroup API. It is a training, so I am going to go particularly slow. We're going to look at a lot of code in the beginning, so just bear with me. What we will do is we will look through some examples. I will then build that example. We will see it work in person. And then hopefully you will be wiser and be able to do this yourself. So, my name's Anthony, and I like learning things. I'm a consultant here at Unity, and what that means is that you might be developing a project, and maybe you've encountered a problem along the way, and you could really need some Unity advice. Well, you can reach out to us here at Unity, and we can look at that project, either come to your office or you can share it with us, and we'll run that project through several profilers, and we'll tell you where your bottlenecks are and how to improve it. So, as it says, I like learning things. And the more I find out, the more I realize that I don't know what's going on. How fortunate that you have discovered the way of wisdom. A discussion between Moneo and Leto, God Emperor of Dune. This is very much a Dunning-Kruger type of comment. As you learn game development, you're going to learn a lot of stuff. You're going to learn about shaders. You're going to learn about physics, about AI. Culling is just another thing you're going to learn, one piece in a larger puzzle. And the thing about knowledge is you really don't understand how much you know until you realize how little you know. And this is one of those type of comments that says you will broaden yourself the more you accept that you know very little. Because by the end of it, once you learn it all, you will learn quite a bit. And at the end of this particular seminar, I'm hoping that you will feel inspired and motivated to do more culling, to apply this knowledge in other ways. So for today, we will be using a GitHub repository, which I used in my previous culling example. You can find it at github.com/UnityAnthony/CullingTricks. Feel free to grab it and follow along, or just wait till the afterwards and take a look. We're going to do a little overview of culling, and then we're going to do a deep dive into the CullingGroup API. We're going to look at all the classes, and we're going to look at some components I've built. Then we're going to build that example, and we're going to show you how to do that. And then I got a little bonus thing planned for you. And then we'll sum this whole thing up and open up the floor to questions. So, culling, what is it? Well, all objects are evaluated for culling before dispatching the initial draw call. Culling is the act of removing geometry for faster execution. You're going to get some types of culling automatically, like frustum culling happens during rasterization. And when we reduce the amount of objects through culling, we will be reducing power usage. And we do that because the GPU is doing less things. But one thing to note about culling is that it can consume a lot of time during the setup. What we see here is a snapshot of a URP capture, and we're setting up the draw calls. Essentially, this is for one camera, and I want you to note that the camera setup is 14.5 milliseconds. And of that, the culling area, which is marked as that cull scriptable, is taking nearly 7 milliseconds. So nearly half your time of setting up the camera in this example is going towards culling. This is one of the reasons why we always say disable cameras if you're not using them, because cameras have to go through certain processes to set up the draw call, even if they're not going to render anything. If they're out there running, they still have to go through all this time, and this time happens on the main thread. So this takes up time for you to do your frame. And so if we can reduce the time needed to cull something, then it will improve overall frame performance and have your game run much more smoothly. So today we are going to look at culling groups particularly. What is it? Well, it's an API. It is executed during the culling pass. That marker we just looked at, cull scriptable, that's where it happens inside the engine. And it is responsible for giving us a callback when the visibility of an object changes, or when the object changes a distance from a reference point. The good stuff, it's easy to use. It works with other culling solutions. So if you want to use GPU culling or Umbra, this works in conjunction with that. It gives you total control on how game objects are culled, and it can be applied to static and dynamic objects. The cons. Well, algorithmically, as we will see here in a minute, that each group has a reference to an array of bounding spheres. So if you have too many groups, it won't be as performant as it would be if instead you had one group with many spheres. And we'll talk a little bit more about that in a bit, but think of it like this. From an algorithmic point of view, the group is the outer loop, the sphere iteration is the inner loop. We don't want to be doing a lot of outer loop looping to do a lot of little loops. So it's a lot more efficient and performant to have one group of 1,000 spheres than to have 10 groups of 100 spheres. Now you've noticed I've said sphere a couple of times. That means that this array that we're talking, that we would loop around, it needs to have some type of management. We need to be able to add and remove spheres from this array. So we have to do that ourselves. The other things to note is that you have to be in play mode. There is no editor tooling. So the classes. There is a CullingGroup class. It's going to contain an array of bounding spheres. It's also going to have a reference location. It'll have a target camera. It'll have a callback for when state changes. And optionally, you can also provide an array of distances. Now, the bounding sphere, all it really needs is a position and a radius, because it is sort of the representation of what is the thing that I want to be aware of if it is being culled or not. So the responsibility of the culling group, it's there to dispatch a callback when a particular bounding sphere's cull state changes, or when a bounding sphere's distance range changes. The bounding sphere should represent the location of an object, including all meshes and even the shadow. And what I mean by that is this is going to be a sphere that represents what you can see. And so if the object that you are culling is casting a shadow and you're not really looking at that bounding sphere, when you do look at it, you would see that shadow pop into existence, right? So you got to make sure that bounding sphere is big enough to accommodate things like the shadow casting or any other arbitrary mesh that might be attached to that game object. Luckily, I've made you some components. The first is the cull sphere. This represents a single bounding sphere. This is essentially a one-to-one for our bounding spheres. We set the bounding sphere's location and radius. We will hold on to the index of that sphere inside the larger array. Because the culling manager is going to hold on to this array, that's where our index is used. It also will update the position and radius of the sphere at runtime if you so choose. So the logic I've created allows you to do some dynamic movements with your object. Maybe you have an object that gets bigger. Maybe that's part of your game mechanic, or maybe it gets smaller. Well, you want that radius to also shrink accordingly, and we can track that. And we also give you a nice gizmo to visualize the bounding sphere. We have this thing called the culling manager. It is the thing that's going to hold our culling group. It's also going to hold on to the array of bounding spheres. And of course, since it holds these spheres, it's going to be the thing that manages adding and removing bounding spheres. And then finally, we have our unit. This is the thing that you want to be culled. It could be an NPC. It could be a tree in a forest. That's up to you how you use this. It's going to have a reference to the cull sphere, and it's going to receive the callback from the culling group, which is on the culling manager. That callback is where we can do all of our custom culling. In our examples today, will be just enabling and disabling components, i.e. the renderers. So let's look at this code now. The cull sphere. We got a radius. We have a debug. This debug bool is used just to help you see the sphere. We'll look at that in just a moment. We have our culling index. We've set it to -1 just so we know that when we go live, we can check that index, make sure it's set to be unique. We have this can update bool. Basically, when we want to track position and rotation, we want to make sure everything's set up. And so this can update will help us inform the cull sphere that it's ready to be monitored. We'll have a reference to the culling manager. And then internally, we have our last radius and last position. When a cull sphere is awoken, it's going to find the culling manager. If a culling sphere is ever destroyed, it will likely already be registered into the culling manager, and we'll want to remove that sphere from the culling manager. So that's why we have remove sphere on destroy. For get sphere, this is where we actually create our bounding sphere. This component will be on a game object. So we're going to give that game object's position as the position for the bounding sphere. And then whatever our radius is will also be used to initialize the object. And then we have our late update. Late update is what we're using to track position and radius. As you can see, we have our can update bool. So if it's not ready, it's not going to do anything. But if it is ready, and when you've got a manager and the manager has spheres, well, we're going to keep track of that last position and radius. If either the position changes or the last radius changes, we are going to update the sphere data in the culling manager sphere array. Now we have some nice support methods, setting can update, getter setters for our index, and then we have our on draw gizmo selected. Notice that it needs to be in debug to show up. And then we have two little if else below, if you will. The first one that's inside the if block, notice it's referencing the culling manager's sphere array. This is what would be used during runtime. If you had to sort of push play and sort of finesse things around, this is where it's getting its information. But if you're not in play mode, you would just use that game object's position and radius to determine how to draw our little sphere. All right, so let's look at the culling manager. First thing, we see that it has a culling group, and it has an array of bounding spheres. We also have a max number of spheres. It is a public variable. Feel free to adjust this. For instance, if you don't have a lot of cullable objects, 500 is perfectly fine. But if you have like a forest of 5,000 trees and you want each tree to be culled, you probably want to increase that to be over 5,000. We have a dictionary. This is what we're going to use to keep track of a cull sphere and its index, basically making sure that it is registered into our system. We also have current max sphere index. And then we have these distances. These are our distance array. And I want to take a moment here to talk a little bit about the distances. If we use the distances, when an object changes a distance, it's not going to give us a number like 25, 50, or 100. It's going to give us the index of which range it is in. So if the object is between 0 to 25, we will receive the index of 0, 25 to 50, the index of 1, and 50 to 100, the index of 2. If the object was beyond 100 units from your reference point, it would be considered invisible. And you would receive events indicating that it's invisible. If you do not want it to ever go invisible, you actually need to change that third number via code to be something like float, max number, or infinity, or something like that. But just be aware that when you use distances, that last digit, that last number is going to be considered like the far plane, the very furthest you could ever see that object. So when the culling manager wakes up, what it's going to do, it's going to set up the cull spheres. Now, it's going to set up the cull spheres based on what is in the scene. So these are sort of like all the static objects that's baked into the scene at the moment the culling manager is awake. If it's ever destroyed, we want to clean up our groups and spheres. So we do a little dispose and null out those properties. But let's look at cull spheres, set up cull spheres. So set up cull spheres. It creates a new cull group. Now each group has a target manager, in this case, or target camera. In this case, we are using a camera which is marked main camera. If you've ever noticed, when you select a camera under tags, you can set it as main camera. Now it will encounter the first camera marked main camera. Really, you shouldn't have other cameras marked main camera, but just so you know how it would work is it would encounter the first one and say, hey, that's the main camera. So we're just assigning that to the group's target camera. This is the camera, and its frustum is being used to determine, can I see it, can I not see it? Then we set up our bounding sphere array based off of our max cull spheres. And at that moment, we then grab all the cull spheres in the scene by doing a find objects of type. And side note, in Unity 6, we're moving towards a find objects by type. And it would have an additional parameter where it allows you to sort or not. This version, find objects of type, already applies some sorting for us. So we would get an array of these cull spheres. We'd look at our dictionary, we clear that out. And then I just have a little warning, just in case you have more cull spheres in the scenes than you have allocated in your bounding sphere array. Just put a little warning on there. It's not going to stop you, but once you exceed your maximum amount of bounding spheres, you're going to start to see some noise in the console. So then what do? We just loop through all of those cull spheres. We add it to the dictionary based off the index. We then tell the cull sphere, here is the index for this cull sphere. We get the bounding sphere from the cull sphere and assign it to the array of spheres. We set the cull manager, and then we say everything's okay, we can now update. With that set up, we know that the current max spheres at this point is the size of the cull spheres in the scene. And so we then tell the group, here are all the spheres that we want, and here are the current spheres. Use up to this amount. And so let's say there's only 50 in the scene at this point. Well, we have this huge array of 500 bounding spheres, but we're only using the first 50. We're still giving that array of 500 to the group, but we're telling only go up to 50. That's why we give it the sphere count. Optionally, also, if you want to, you can set up distances, provide those distances, And if you do use distances, you need to set a reference point. And in this case, I am setting up the camera, the main camera. So then we have the option to add a sphere dynamically. This is what would happen for a object that has a cull sphere on it and it's instantiated at runtime. Well, what we first do is check to make sure that this index isn't already in our dictionary. If it's not, we continue on. And then what we will do is we will loop through our array looking for the very first available slot that's not already in our dictionary. We tell the cull spheres to set its index. We add it to the dictionary. We get the bounding sphere for it. We tell it to update. Because we just added one more thing, we increase our max by 1. And because the array of spheres has changed, we give the group the new set of array and we tell it, here's our new max. Easy enough. To remove cull spheres, we're going to do a couple tricky things. If you remember last time, I just sort of reduced the amount of max spheres each time. That was not the right algorithm. This is the right algorithm. Here, we give you the option if you want to provide the cull sphere, we can do that. We get the index, we pass it to the cull sphere that takes the index. And we do this remove and compact. So imagine what happens is you have that little, that subset of the array and you're taking something out of the middle. What we're going to do is we'll want to take the thing that's at the very last location and put it into the location that we are removing. Then we can shrink it by 1, and it's going to keep that array nice and tight. So what do? We make sure that the cull sphere is inside of our dictionary. We get the index of the last object. We hold on to the cull sphere that we want to remove. We hold on to the cull sphere which is at the last location. We tell the one that we want to remove, stop updating, we're taking you out of the dictionary. Logically, you're gone at this point. If the location is not the last location, if it's somewhere that is not the very last in that array, what we're going to do is we're going to grab the bounding sphere that was at the last location, and we will assign it to the location of the one that we were removing. Then we remove the last index from the dictionary. We tell what was the last culling sphere. This is the new index to use. We update the dictionary accordingly. Now that we've done this little swap, we can shrink our current max spheres. We have to update the sphere set. We have to update the current max spheres. Which leads us to the unit. And the unit, this is the thing that could be the NPC, that could be the tree. It has a reference to a cull sphere. It has reference to renderers, an array of renderers, whatever you want to turn off. And it has a reference to the culling manager. When it starts, it'll find the culling manager. And then if there is a caller and there's a culling manager, it's going to add its sphere to the culling manager. At that point, it should have an index. So we'll grab the index and we look at the culling group's on state change and we subscribe to our own method or have our own method subscribe to that. And we'll call our own method on color state change. And then once it's sort of already registered in the system, what we can do is we can look at the culling manager and the group on the culling manager and determine, is this particular object visible based off of that index? And so what we do in show render is we pass true or false if we can see this stuff. Obviously, if this object gets destroyed, we want to unregister from the onState change. So we cover that in there. And then this is the big glue. This is the thing that does the magic. When any of the the bounding spheres change, all of them are going to receive a message in the form of a CullingGroup event. That CullingGroup event is going to have the index of the particular object that is actually changed, that's associated with this event. This is why we want to keep track of that index. So what we do is we look at the Colors index, we make sure